Hello, I'm Bill Serban, Director of the Center for Advancing Teaching and Learning at the University of Wisconsin-La Crosse. This brief presentation is about transfer of learning. In it, I will define transfer of learning, examine some of the reasons why transfer is difficult, and offer several recommendations about how to support better transfer of learning among your students. Transfer of learning involves the application of skills, rules, facts, concepts, or procedures learned in one situation to a different situation. Transfer is synonymous with application. We apply what we know to solve new problems and develop new ideas. Transfer of learning occurs when you do things like apply punctuation rules learned in a writing class to composing a job application letter. Use basic arithmetic procedures to create a personal budget. Use appropriate statistical procedures for a research project in another field of study. Drive a tractor for the first time, using skills you learned from driving other types of vehicles. Encounter a new word, and then start using it appropriately in different settings. These examples suggest that transfer is commonplace. It is. We learn something and then apply it later in situations where it is productive and appropriate. Education is predicated on the assumption that transfer of learning will take place. We assume that knowledge and skills students learn in one class will transfer to another class. We assume that knowledge and skills students learn in school will transfer to life outside of school. Yet, it is the lack of transfer that gets our attention. Teachers witness transfer failures on a daily basis. They see students who learn something in one situation and then do not apply it where it is relevant. Students who have taken a statistics course are unable to identify an appropriate statistical test for their research project in their psychology class. Students who did well in their writing composition course write relatively poorly on their history papers. Students in chemistry appear not to know algebra when they need it to balance chemical equations. Sometimes the transfer failures are epic, or at least surprising. Consider two examples. In a national test with 45,000 students, 13-year-olds were given the following problem. An army bus holds 36 soldiers. If 1,128 soldiers are being bused to their training site, how many buses are needed? 70% of the students performed the division correctly, but 29% wrote that the number of buses was 31, remainder 12. And another 18% wrote that the number of buses was 31. Only 23% gave the correct answer. These results indicate partial transfer. A majority of students could apply their knowledge of division to the problem and do the arithmetic correctly. But their answers suggest that most students don't see the relationship between the arithmetic and the actual problem. 29% did not seem to recognize that the remainder of 12 referred to 12 soldiers in need of a bus. This may indicate that the children have a routinized understanding of division. They can do the procedure to get correct answers, but lack an understanding of what the numbers represent. To them, a remainder is just a number left over after you divide. A second example is a kind of transfer anomaly and comes from observations of how people use mathematics in everyday situations. Researchers observed individuals participating in a Weight Watchers program solve everyday measurement problems. In this situation, the diet allowed 1/2 cup cottage cheese per day, and the individual needed to figure out the portion size for 3 equal portions during the day. A quick mathematical solution is to determine 1/3 of 1/2 cup. Multiply the fractions, the answer is 1/6 cup. But the actual strategy used was a bit different. In one case, the individual measured out 1/2 cup of cottage cheese, patted it into a circle, and then took 1/3 of it. This example is interesting. The person gets the correct answer without drawing upon formal school mathematics. where one learns to manipulate quantities. The person was, however, able to draw upon prior knowledge to solve the problem, just not the kind of knowledge we would expect an adult to produce. Let's explore transfer failures by looking at two factors that play a significant role in transfer of learning. One is the initial learning of the individual. A second is the similarity between the initial learning context and the new context or situation where we expect knowledge to be applied. The key factor is the level or depth of students' initial learning of the subject matter or skills. We can't quantify depth of understanding, but we can distinguish between shallow and deeper understanding. When our understanding is shallow, our grasp of a topic is fragmented, piecemeal, concrete, inflexible, naive, superficial, underdeveloped, and incomplete. In contrast, when we have deeper understanding, our grasp is well-developed, fluent, elaborated. We see similarities and differences between concepts. We perceive abstract relations. Our understanding is insightful and more nuanced. Research does show that when students have poor understanding of a topic, transfer is not likely. When they have a deeper grasp, they are better able to transfer, although transfer is not a sure thing. There's a larger context to consider here. Students are usually in situations where they encounter large amounts of new information. It is helpful to think about the students as being novices in your field of study. They are starting out with some level of prior knowledge, but it is vastly different than in experts. Students not only know less, but their knowledge tends to be organized differently than experts. As a result, their ability to use information may be halting and inflexible. Here is one example to illustrate the important difference between novices and expert. This study asked undergraduate physics students and expert physicists to categorize a set of physics problems. That is, to group the problems similar to one another. Here's what they found. Novices looked at the physics problems and grouped them based on the actual surface features of the problem. On this slide, you see two problems that depict an inclined plane. Undergraduates saw these problems as similar, regardless of the underlying physical laws or principles involved in the problems. In contrast, experts group problems based on the underlying physical laws or principles, regardless of the surface features. Clearly, novices do not yet understand physics deeply, and this prevents them from developing effective representations of the problems. We would not expect them to transfer their incomplete understanding to new problems very effectively. Depth of initial understanding, then, is an important condition for effective transfer.
A second factor that affects transfer is the degree of similarity between the context in which students learn a concept or skill and the context where they are expected to apply it. For example, suppose you've just learned a new concept in class. The contexts where you may use the concept may be dissimilar or more physically distant from where you learned it. If you learn a concept and then are asked to practice solving identical problems in class, the two contexts are very similar. Same setting, same problems, no time delay. But then if you're asked to solve a set of problems for homework, these are still similar types of problems, but now there's a delay between the initial learning and the new context. Then you take a test 3 weeks later, which has some of the same types of problems, but it is 3 weeks later, and the situation is more high stakes, introducing stress and anxiety into the context. Then, in a different course, either the same term or a later term, you encounter problems where the concept is relevant. Now the context is significantly different, not just in terms of time, but the surrounding background information present in the situation. You learned a math concept in math, but now you're in a chemistry class. Things look different, and it may be hard to map the math concepts onto chemistry problems. And finally, you may encounter real-life situations outside of school where your knowledge is relevant, but the context may be so different that you don't see its relevancy at all. Ostensibly, the more dissimilar the contexts, the more difficult transfer is likely to be. But it is not just physical and time difference that matter. When students can't or don't apply their knowledge to new problems, we have to ask how well students understood the material and whether they can see the relationship to the new context. Often, what is obvious for the expert is non-obvious to the novice. Now we turn to recommendations about how to support better transfer of learning among your students. Teachers have gone to great lengths to promote transfer. Problem-based learning originated in part from an effort to help students learn to apply their knowledge to complex, open-ended problems. For example, medical educators report that there's a significant gap between medical students' foundational knowledge and their ability to apply it in diagnosing patients. Some medical programs have adopted problem-based curricula in which students learn much of the foundational knowledge in the context of trying to solve medical cases. Short of adopting new pedagogical approaches, what can teachers do to nudge students toward better application of knowledge and skills? As expected, there's no single best teaching technique that will make transfer happen. As teachers, we can be mindful of the barriers that inhibit transfer and more deliberate in giving students the kind of experience and practice that will help them apply their knowledge and skills. In some respects, we won't know whether our efforts are successful. We may be trying to prepare students to do something that we will not actually witness firsthand because it will take place in the future. Nevertheless, here are 6 recommendations. First, help students achieve initial learning that is necessary to support transfer. As we've seen, deep understanding of a concept or skill increases the chances that students will be able to use that knowledge. There's no way to quantify how much is enough. However, teachers might examine transfer failures in their classes. This may help pinpoint some of the gaps in understanding that derail transfer. In skills courses, instructors can help promote transfer by asking students to overlearn important skills. Overlearn means become increasingly adept or fluent at performing the skill. Practice transfer in class. To the extent possible, involve students in transfer tasks and exercises in class. These can be low-stakes, brief activities. For example, during class, ask students to apply a new concept or skill. Then, write a quick response. Discuss it with a classmate, and then, as instructor, you can use several student responses to give feedback to the class. Provide hints or prompts. If students encounter roadblocks and really can't do application exercises, intervene with hints or prompts. Provide just enough information to point them in the right direction. Expose students to concepts or procedures in multiple contexts. To the extent possible, expose students to concepts and skills in multiple situations. Much of what students learn in school becomes context dependent. Students acquire significant learning skills in composition course, but don't apply them to writing assignments in other classes. Exhorting students to use what they know is probably not very effective, but giving students a variety of assignments where they use skills in multiple contexts can help them develop a more abstract concept of writing that becomes independent of the context. Make conditions of applicability explicit. Teachers can help students understand where and how their new knowledge and skills are relevant. Students usually don't know where or how what they learn in one class may be used or relevant in another class. Teachers can help by pointing to concrete examples of where their knowledge will be useful. And then finally, instructors can create bridging experiences between classes. Instructors often say that students come into their classes not having prerequisite knowledge or skills. A more realistic appraisal is that students' knowledge or skills is inflexible. They are not yet adept at using their knowledge in new circumstances or fail to recognize the relevance of what they know. This is a problem that teachers can approach collectively by creating bridging experiences that remind, activate, and refresh students' prior knowledge and skills. For instance, an instructor could develop short reviews of concepts learned in a previous class and illustrate how those ideas will be useful for new learning in the class. This can help reactivate students' knowledge and also connect them to the contexts where the material will be relevant.